Hi everyone, you are watching channel Maths and Method Academy. Today we are going to learn about matrix. So what's the matrix? A rectangular array or a formation of a collection of real numbers such as 0, 1, 2, 3, 5, 9, etc. in the form of rows and columns and then enclosed by brackets is known to form a matrix. So let's see some example of a matrix. Like A is a matrix, 1, 3, 5, 9, 2, 7. So A is a matrix. It has 2 rows and 3 columns which are enclosed by brackets. This is one example of matrix. Let's write another one. 1, 3, 5, 7. This is a matrix of order 2. It has 2 rows and 2 columns. The plural of a matrix is known as matrices. This is how we write it, matrices. Let's talk about different types of matrices, but before that we will try to understand what a matrix is all about, how it is addressed and how its elements are addressed. Suppose we have a matrix A which has 3 rows and 3 columns. This is the matrix A. It has 3 rows. This is row 1. This one is row 2. And this one is row 3. Similarly, it has 3 columns. Those columns are column number 1, we will call it C1. Column number 2 we will call C3, and this is column number 3, we will call it C3. So this is C1, column number 1, C2, column number 2, and C3, column number 3. Similarly, this row is the first row, then the second one, and then the third one. So this is a matrix of order 3 by 3. First we write number of rows, which is 3, then we write by, and then we write column. So this is a matrix of order 3 by 3. Let's have another example. We have a matrix B. It has 6 entries, 0, 3, 5, 7, 9, 11. This is the matrix of order 2 by 3 because it has 2 rows. This is row number 1. This is row number 2. Similarly, this is column number 1. This is column number 2. And this is column number 3. So this is a matrix of order 2. First of all we write rows, then by 3 is the number of columns. So it is very clear to us now what a matrix is. So all the entries presented in vertical way are called columns. Vertical way means these are vertical ways. These are all called columns. 0, 7 is the first column, 3, 9 is the second column, 5, 11 is the third column. And all the entries presented in horizontal way are called rows. So this is horizontal, this is horizontal, This is horizontal, so it has how many rows? R1 first row, R2 second row, so it has 2 rows. So basically it is a matrix of 2 rows by 3 columns. Generally we don't write like this, we say 2 by 3. Instead of writing it like 2 rows by 3 columns, we simply omit row and 3, which is understood that the first number is for row and the second number which comes after by, it is for column. So we call it 2 by 3 matrix. Now we know that matrix has rows and columns, and when we say that this matrix B, its order is 2 by 3, it means it has 2 rows and 3 columns. When two matrices are said to be equal. When two matrices are said to be equal, there are two conditions that should be fulfilled. Number one, their order should be same, that their number of rows and number of columns should be same. Then their corresponding entries should be same. Let's explain it with the help of an example. Suppose we have a matrix A, its entries are 1, 3, -4 and 2. Then we have a matrix B, its entries are 1, -4, here it is 2 plus 1, here it is 4 minus 2. Now we will compare in both the matrix the position of its elements. Like this position will be compared with the corresponding position in the other matrix, which is matrix B. Both are 1, then we see that -4 is here, -4 is here, then we see 3 is here, 2 plus 1 is also 3, okay, this is also 3, then 2 is here and 4 minus 2 is 2, 2 is here as well. Since all the entries are equal, therefore these two matrices are equal. Let's take another example. We have a matrix L equal to 2, 3, -1 and 2. Then we have a matrix M. Its entries are 2, 3, -1, -2. Let's apply both the conditions here. The first condition, that their order should be same, that condition is okay. Both are fulfilling this condition. Now we go to the second condition, where the entries of both the matrices should be same. So first we check the first one. 2 is equal to 2, that's fine. 3 is equal to 3, that is fine. -1 is equal to -1, okay. But the fourth entry, which is this one and this one, they are actually not equal. In one matrix it is 2 and in the other one, which is M, the entry is -2. So it means L is not equal to M. But here in this case, A is equal to B. Let's have another example. Suppose P is equal to 2, 3, minus 1 and 2, and then we have another matrix which is Q. Its entries are 2, 3, 4, minus 1, 2, and then 0. Okay, now again we will apply both the conditions here, that is the order should be same and the entry should be equal. Here these two matrices, they are not even fulfilling the first condition because the order of P is 2 by 2, whereas the order of Q is 2 by 3. So these two matrices, they are not equal. Now we will try to differentiate between the different types of matrices. There are 12 types of matrices, and now we will learn how to figure out which type is which one. So let us write down first the different types of matrices. The first type is row matrix. The second type is column matrix. The third type is rectangular matrix. Then the fourth type is square matrix. Then the fifth type is null or zero matrix. Then the sixth one is transpose of a matrix. Seventh one is negative of a matrix. Eighth one is symmetric matrix. Ninth one is Skew-Symmetric matrix. Tenth one is diagonal matrix. 11th one is scalar matrix. And the 12th and the last one is identity matrix. Now we will try to understand each one of them. That is how we can recognize which matrix is which one. Okay, the first one written here is row matrix. A matrix is called row matrix if it has only one row. So let's take an example. Suppose we have a matrix M. So it has elements 2, -1 and 7. Now you can see that this matrix has 3 columns and only one row. So any matrix with only one row will be known as row matrix. So the order of this matrix is 1 by 3. Let's take another example. Suppose M is equal to 1 -1. This is again a row matrix and the order is 1 by 2. our second type is column matrix. So what is column matrix? Like row matrix where there is only one row in the matrix, similarly in a column matrix there will be only one column. So any matrix is called a column matrix if it has only one column. So its example is M is equal to 1 0. So you can see there are two rows and one column. Its order is 2 by 1. Let's take another example. Suppose M is equal to 2 0 1. Again we have only one column and three rows. So how we will write its order? First the number of rows, which are 3, and only one column is there, so the order is 3 by 1. Okay, the third type, rectangular matrix. A matrix is known as a rectangular matrix if its number of rows and number of columns are not equal. Following are the examples. For example, A is equal to 1 2 1 1 2 7. You can see that here number of rows are 3 and number of columns are 2, which are unequal. That's why it's a rectangular matrix. Let's write down another one. Matrix B is A B C D E F. Here we have 2 rows and 3 columns, which are again unequal. 2 by 3, number of columns are not equal to number of rows. So this is a rectangular matrix. Same in the first case, it was having 3 rows, 3 by, and the columns are 2. So this is our rectangular matrix. Fourth type of matrix is square matrix. Very simple. A matrix with equal number of rows and columns is known as square matrix. Its examples are A is equal to 2 minus 1 0 3. So here its order is 2 by 2, means number of rows and columns are equal. Then we have B 1 2 3 4 5 6 7 8 9. Its order is 3 by 3, which means it is a square matrix. Its number of rows and number of columns are equal. Another example, C is equal to 3. This is a matrix and its order is 1 by 1. 1 row, 1 column. The fifth type is null or zero matrix. Null or zero matrix. Very simple. A matrix is called null or zero matrix if all its entries are 0. Its examples are A is equal to 0 0 0 0. It's a matrix of order 2 by 2. Its order is 2 by 2, but its all entries are 0. That's why this matrix is known as null or zero matrix of order 2 by 2. Let's take another example. Again, all the entries of this matrix are 0. So it is a null or zero matrix of order 2 by 3. Take another example. This is also, C is also a null matrix or zero matrix, and it is of order 2 by 1. Generally, a null matrix is represented by O, capital O. Let's write it down here so we don't forget. A null matrix is represented by capital O. Okay. The sixth type is transpose of a matrix. A matrix obtained by changing the rows into columns or columns into rows is called transpose of a matrix. So if A is a matrix, then if A is a matrix, then its transpose is denoted by AT. Let us take some examples. If A is equal to 1, 2, 3, 2, 1, 0, minus 1, 4, minus 2. Now, how we will form a transpose of this? Very simple. How many rows it has? It has 3 rows. Let us mark those rows. This is row number 1. This is 2. This is 3. 1, 2, 3. Now what we will do, and this is the column C1, C2 and C3. What we will do, we will bring the elements of R1 into the place of C1. So how we will do it? Let's see. AT is equal to, this is the first row, we will make it first column, so we will write it like this: 1, 2, 3. Then we will pick up the second row and we will write the elements of or entries of second row into the position of second column. So it will come like 2, 1, 0. Then we will do the same thing with row number 3. We will write its entries in the position of column number 3. So we will write minus 1, 4 and minus 2. So this is the transpose of a matrix, and this is how we find it out. Let's take another example. Suppose we have a matrix B which is equal to 1, 0, 2, 2, minus 1, 3. Again we will do the same thing. This is R1, this is R2. Now we will pick up the entries of row 1 and we will place it in the position of column number 1. So transpose of B is equal to 1, 0, 2. These are the elements which we are putting in the first column. These are the elements of row number 1. Now we will pick up the elements of entries or elements of row number 2 and we will write it in the place of column number 2. So it will be 2, minus 1 and 3. Now you can see that the order of the matrix has changed. The order of B was 2 by 3. Now the order of its transpose is 3 by 2. So this one is 2 by 3, the order of B, and the order of transpose of B is 3 by 2. Let's take another example. C is equal to 0 and 1. This is actually a row matrix, and the transpose of a row matrix is always a column matrix. So this is row 1 and we will place its entries in the column 1 of the transpose of C. So we will write it like 0, 1. So transpose of a row matrix is a column matrix. So if we generalize it, if M and N denote row and column of a matrix, then its order is M by N and the order of its transpose matrix is N by M. I hope it is clear to you. Not a very difficult thing. Now we move on to our 7th type, negative of a matrix. Negative of a matrix. Okay. Let A be a matrix, then its negative, that is minus A, is obtained by multiplying all its elements or all its entries by minus 1. The example is, if A is equal to 1, minus 2, 3, 4. What we have to do, in order to get its negative matrix, we have to multiply all its entries by minus 1. So 1 into minus 1 is minus 1, minus 2 multiplied by minus 1 is positive 2. Then 3 multiplied by minus 1 is minus 3 and 4 multiplied by minus 1 is minus 4. So this is the negative matrix of the given matrix. So matrix was A, so its negative A will be equal to, as it is showing here, we move on to our 8th type. 8th type is symmetric matrix. Now, what is a symmetric matrix? A square matrix is symmetric if it is equal to its transpose. That is, matrix A is symmetric if A is equal to A transpose. Like suppose we have a matrix A and its entries are 1, 2, 3, 82, 3, minus 1, 4, 4, 0. So this is our row 1, this is our row 2, and this is our row 3. Now we are going to write a transpose of A where we have to write the the entries of rows in place of columns. So the entries of row 1 we will write in the place of column. It will come like 1, then 2, and then 3. So this row we have put into the column place, the first column. Similarly, second one we will write this 2 here, this minus 1 here, this 4 here. Then the third one we will take this 3 and put it here, 4 here, 0 here. Now you can see that the elements of the entries of A and entries of AT, they are the same, which means A is equal to A transpose, and when this condition is met, that type of matrix is called symmetric matrix. Okay, now we move on to our ninth type. Ninth type is skew-symmetric matrix. Now, what is skew-symmetric matrix? A square matrix A is said to be skew-symmetric if A transpose is equal to minus A. Okay, so a matrix is skew-symmetric if A transpose is equal to minus A. Let us try to understand it with the help of an example. So suppose A is equal to 0, 2, 3, minus 2, 0, 1, minus 3, 1, 0. Now let us write down its transpose first. So A transpose is equal to, same thing we have to do, we will take row 1 and we will put it in the place of column 1 of the transpose. So it will come like 0, 2, 3. Then we will take the second row and we will put its element in column 2. So minus 2, 0, 1. And then the third one we will write minus 3, 1 and 0. Okay, so what we will do now, we will take minus 1 common from all the entries of A transpose. So when we will take minus 1 common, we see that A transpose equal to minus outside. So all the signs inside the matrix, the signs of all the entries inside the matrix, they will change. First is 0, so it will remain 0. Minus 2 will become 2. Minus 3 will become 3. 2 will become minus 2. 0 will remain as same. And 1 will be minus 1. 3 will be minus 3. 1 will be minus 1. And then 0. And you can see now this one and this one is equal. So since it is equal, we can replace this one with its name, like which is A. So we can write it like A transpose is equal to minus A. So since this condition is met, that A transpose is equal to minus A, it means the given matrix A is a skew-symmetric matrix. Our 10th type, diagonal matrix. Now, what is a diagonal matrix? A square matrix A is called a diagonal matrix if at least any one of the entries of its diagonal is not 0. Again, I will repeat. A square matrix A is called a diagonal matrix if at least any one of the entries of its diagonal is not 0 and non-diagonal entries are 0. Let's take an example. A is equal to 1, 0, 0, 0, 2, 0, 0, 0, 3. Now, we were talking about a diagonal. Which diagonal is that? It is this one. What we have said in the beginning, a square matrix, this is a square matrix of 3 by 3. A is called a diagonal matrix if at least any one of the entries of its diagonal is not 0. All its entries in the diagonal are not 0. So this condition is also fulfilled. And the third is, and non-diagonal entries, all non-diagonal entries are 0. So these are all 9 diagonal entries, 3 there and 3 here, and you can see all of them are 0. It means this matrix A is a diagonal matrix. Let's move on to our 11th type. 11th type is scalar matrix. Now, what is scalar matrix? A diagonal matrix is called a scalar matrix if all the values of its diagonal are equal. Very simple. Let's take an example. Suppose we have a matrix A which is equal to 3, 0, 0, 0, 3, 0, 0, 0, 3. Now you can see it is a diagonal matrix, and the last condition which is required for a matrix being a scalar matrix is that all the values of the diagonal should be equal. So this is the diagonal, and you can see all its entries are 3, which means this matrix is a scalar matrix. Twelfth and the last type, identity matrix. Okay, now what's an identity matrix? A diagonal matrix is called identity or unit matrix if all diagonal entries are 1. Very simple. Let's take an example. We have a matrix A is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the diagonal, and you can see that all its entries are 1, and other than this diagonal, whatever entry is there, it is 0. So this type of matrix is known as identity matrix, and it is denoted by I. Most of the time you write it like I. More examples, like if we have B 1, 0, 0, 1, this is also a diagonal matrix, and we have another matrix which is having 1 row 1 column. This is also an identity matrix. B is identity matrix and C is identity matrix and A is also a identity matrix. Okay, so that's all for now. I think you would have understood all the types of matrices. That's it. So take care, and until the next time, bye bye.